In this video, we'll show you how to recognize sample charging. Just for the purposes of this video, I have my beam set to 2 kV, my filament current at 0.87, which is correct for this CMA to give me about 300 nanoamps of target current. I've set up a survey. Let's acquire the survey. Okay, so you can see I'm getting data. I'm on just the sample mount, which is very dirty. Usually has carbon on it, because we don't sputter it. So that's what I'm seeing, just basically a carbon peak. Alright, so let's go ahead and stop this acquisition. Now what I'm going to do is I'm going to move to a piece of phosphor. Phosphor is useful for looking at the electron beam or an ion beam, for example, but it does charge. So let's go ahead and start the acquisition under the exact same conditions. And what we expect to see is some instability in the background, and sometimes it'll charge up and just saturate the multiplier. You see that instability? There, it just charged up. Discharge. So the sample is charging and discharging. When it discharges, we get a little bit of data. Well, not really, because it's so unstable. Alright, that's what charging looks like. So if you see charging, that means that your sample either is non-conductive or you have a bad contact with the sample to your manipulator, or your manipulator is not grounded. So you'll want to look at those types of things. Auger is only good for semiconductors and conductors. It doesn't work very well for insulators because of this charging effect. What you could do, if you do see charging, is you can try using a lower beam voltage. Like I'm already using 2 kV. That's about as low as you'd want to go probably. And you could lower your target current as well. But charging samples just really do not do very well with Auger, which is why you really need to have semiconductors and conductive samples.